Okay. A particle of mass 0.5 kilograms is suspended from a fixed point P by a spring which executes simple harmonic motion with amplitude 0.2 meters. The period of the motion is 2 seconds. Find the maximum acceleration of the particle. Okay, if we understand simple harmonic motion, where does the maximum acceleration take place? I know I'm currently doing it laterally, but where does the maximum acceleration take place? Anybody? Where'd you say? That's the maximum speed, not the maximum acceleration. Huh? At the amplitude. Takes place at the amplitude. Okay? So, does anybody remember the, the formula for... So, A equals minus omega squared x. However, in this particular case, your x value is what? A. So x value equals capital A. So A equals minus omega squared A. Now what is omega? Period is 2 pi over omega, which is 2. Cross multiply. Omega equals 2 pi over 2. Pi equals omega. Okay. Plug it in. The sign is irrelevant. We know it's going in the opposite direction. Just what's the acceleration? Okay, so the acceleration is going to be pi squared. And what's the amplitude? 0.2, which is minus pi squared over 0.5. You're forgiven for not using the minus. Full marks either way. Okay? Pi squared over 0.5. So when you get to this amplitude, you're going to be going back in with an acceleration of pi squared over... Oh, sorry, over 5, not 0.5, over 5. Pi squared over 5. That right? When you get to the other side, you're going to be going with an acceleration pi squared over 5 in the opposite direction, because you're coming back inside. Make sense? Okay, good. 10 marks for that. 10 out of 25. Moving on. Find the greatest force exerted by the spring correct to one place of decimals. So, as I stated before, we're not talking about a horizontal system, we're talking about a vertical system. So we'll just turn this line upside down for a minute. And what we're going to have is our mass here of weighing us down 0.5 g. The only source keeping us here is tension. Okay, and our maximum acceleration is our pi squared over 5. Now, oh dear. So maximum tension occurs at what point? Greatest extension. Maximum tension is at greatest extension. Your net force going upwards, okay, is going to be, we're talking about up is positive this time around, yeah? Tension goes upwards and it's weighed down by weight. Your force, therefore, is the mass of your object, which is 0.5 kilograms. The acceleration, positive or negative? Positive pi squared over 5 or negative pi squared over 5? Positive pi squared over 5. I'll tell you why. Because we said force going upwards. We made it positive. We decided that we're going to make it positive. You could set up a negative system. That would also work. But it'd just be the -1 version of the formula. So example would be, one formula would be something like this. The other formula would look something like this. They're the same system, except they're -1 versions of each other. Okay? So, force equals 0.5 times the acceleration, which is pi squared over 5. Tension minus 0.5 g. Then we're going to, tension therefore equals 0.5 pi squared over 5 plus 0.5 g. Put all that into the calculator. That's including g equals 9.8. And we're going to get T equals 5.9 newtons. That alright? Okay, so look at this. It lies on the top, and the B particle is here. Okay. Now, is it capable of making it underneath halfway? Because it's not capable of making it underneath halfway, what can you do with this line here? Make that height equal 0, the point at which there's no potential energy. If it's capable of going underneath that, you'd have to lower it down and have that as your reference point of h equals 0. Okay. Now, what is the key thing when you're breaking down, when you're making these triangles and all this? What's the key thing you got to remember again? You're working with the point at which it leaves, not the start. You always work with the end. Okay. So what we're going to do is this. First things first, I'm going to break this up into a bit of a triangle. Where's my snapshot tool here? Okay, so just use this for a second. There we go. Here. So what I'm going to do is just enlarge this a wee bit. Okay, now I'm going to work with this here. So what's the radius? Anybody tell me? Does it tell you the radius? 30 centimeters. It's 0.3 in my language. Okay. All I'm going to do next is I'm going to find out what height B is above it. And I'm going to have to make up an angle. You've named it. I'm going to call it alpha again. That's 0.3 there. So what does that make the height above the ground? 0.3 cos alpha. Is that right? Okay. So I'm going to start off with conservation of energy. P1 plus K1 equals PE2 plus KE2. Okay. Do I start off PE is mg. What's our height? This is at the very beginning. This is this point here. 0.3. K1. Do we start with any speed or do we start from rest? Does it say? Sight of space and slides down. Start off with nothing. mg. What else is going to be there then? mg. What's the height? 0.3 cos alpha. We're good. And then finally a half mv squared. Okay. If I isolate phi squared, so if I isolate, oh crayon, don't want that. If I isolate phi squared, I'm in business. So I'm going to multiply both sides by 2. I'm going to get rid of all the m's. So I'm going to multiply both sides by 0.2, so I'm going to get 0.6g equals 0.6g cos alpha plus phi squared. Phi squared is therefore equal to 0.6g minus 0.6g cos alpha. And stop there. Next, I'm going to use centripetal acceleration. Should I use Fc equals mr omega squared, or should I use mv squared over r? Because it's compatible with the phi squared. Okay, so we're not going to make that mistake. And we're going to go straight in here. And, oh, never mind. So, Fc. Now here's the interesting part. I go back up here. And I start working with this again. So, can't get rid of that for some reason. So, move this up here. Move this picture, that is. Okay. Just get rid of these lines for a second. Now, what I'm going to do with this, in vertical motion questions, okay? In vertical motion questions, what you need to do is you have to look at the radius. You draw in the radius from the point that leaves, and then you draw a tangent to that. And what you're going to do is you're going to break any force along those two lines. The only force I got to worry about is its weight. The R value goes straight up and out. That's no bother. It's the weight that's the problem. So what I'm going to do is going to get a big line here, and I'm just going to draw my weight going downwards, like so. I'm then going to break it up into parallel and perpendicular to the tangent and the radius. Is that alright? Now, how do I determine my angle? I specified earlier that that's angle alpha, and that's what all my other angles are based off. So what does that make this angle here? This one here? alpha by alternate angles. What does that make this one here? Alpha by alternate angles. Then what's this? This is mg going straight down. So what's this part here? Mg cos alpha. And the other one is mg sine alpha. Which one is acting along the radius? Remember, centripetal force always acts back in towards the radius. Acts in along the radius towards the center of the circle. So what is it? So we're going to have mg cos alpha, which is acting along this line here. Take away what? What acts against it? R. And that equals mv squared over 0.3. Look up at the point it leaves. What happens to the R value? 0. So cancel. Then we can cancel the m's because R equals 0 doesn't exist. So we're going to get phi squared equals 0.3g cos alpha. And as it turns out, very compatible with our other equation. So we're going to get 0.3g cos alpha equals 0.6g minus 0.6g cos alpha. Okay, we're going to get 0.9g cos alpha equals 0.6g. We're going to get cos alpha equals 2 over 3. And then what I'm going to do next is I'm just going to construct a quick 3 to root 5 by Pythagoras' theorem, so I can find out what sine alpha is pretty quickly. So look, from that point onwards, I found I haven't quite found its speed yet. So just give me 1 second with that. Phi squared equals 0.3g cos alpha. Phi squared therefore equals 0.3g times 9.8 times 2 over 3. Put it all into the calculator, square root it, and you'll find out that phi is 1.4 ms to the minus 1. Is that right? 1.4 ms to the minus 1. Here comes the tricky part. That was all bog standard, 15 out of 25. Okay. So hopefully you'll be on 40 out of 50 at this stage. Now you're working for your 80 to 100. So this is where they make you work. So we go back to this here. Get rid of all this. Okay, so what we have next is the horizontal distance in meters of the particle from the center of the sphere t seconds after it has left the surface of the sphere is root 5 over 10 kt. Find the value of k correct to 2 places of decimals. Okie dokie. So, horizontal distance. Would that refer to the blue line or the pink line? Pink line. Okay. And then what happens is it gets thrown off the edge, and then it keeps moving. So it gets thrown off at a tangent to that point, and then gravity kicks in. Oh, sorry, it won't go that way. It will go more like arcing downwards like that. Would everybody agree? And I like to find out at any given time what is the distance from this point here to to any point on its motion. So any point on its motion, what I have to do is I have to bring that motion. I just have to find out the horizontal distance, not how high or low it is above the ground. That's my job, okay? So what I could do with, in theory, it's the distance equals its starting distance plus its horizontal velocity multiplied by time. On a really basic level, if I was 10 meters away to begin with, and the horizontal component, I was 10 meters away horizontally to begin with, and the horizontal component of my velocity, so let's say as an example it was a 3, 4, 5 triangle, I'm only concerned with the 3 part, am I? Because that's how far I'm going away horizontally. So it's going to be 10 meters plus 3 times time. I have to do something similar for this equation here. So here's how we're going to do it. Start off with this. That was alpha. That makes that alpha. This is 0.3. That makes this 0.3 sine alpha. Starting distance, the pink line, is 0.3 sine alpha, which is 0.3 root 5 over 3. And what that's going to give me is root 5 over 10. That's the first part checked out and completed. The next part that we're going to have to do is we're going to have to work exclusively on the tangent angle. Okay? So the tangent angle, what you can see here, carry on and you can go. The tangent angle is like this, guys, okay? We have to break up this tangent speed into two components, vertical and horizontal. So this tangent velocity, okay, is that's alpha, makes that 90 minus alpha, makes that over there alpha. So then what we're going to get is it's 1.4, so that makes that 1.4 cos alpha. So the horizontal velocity is 1.4 cos alpha, and 1.4 cos alpha is 1.4 times 2 over 3 times time, which is going to be plus, when you multiply all that out using the calculator, you're going to get 14 over 15 t. 14 over 15 is your k value. K equals 14 over 15.